Hey YouTube, it's Sean, Griffin RC Planes. This is going to be the first video on what we're going to call our intermediate section. This is programming receivers. If you bought an RC airplane, a PNP version, which stands for plug and play, that plane will come with everything but a receiver. So we will show you guys how to set up a receiver in the DX7S first. And we're going to use just a basic AR610 receiver, no gyro, just a simple setup. And we're going to start with this basic receiver because a lot of things we'll show will carry on to the other receivers. And we'll just do a quick video showing how to set up the travels and the dual rates and servo direction and how to make sure the servo arms and the linkage is all good. And then that will be good information to carry on to the next one we do, which is the AR636. And we'll set it up with full safe select and have it on a switch to control it on and off. And we'll use the Spectrum programmer a little bit and the Spectrum app with my tablet. So we'll do that on the next video. But for now, let's get this AR610 mounted into my foam board test RC airplane. If you're new to the channel and you haven't seen the test RC airplane, all the control surfaces are different colors. And that's to help if I say, hey, let's look at the right aileron and we'll see what it's doing in the transmitter here. Green. Then you'll know to look for the green. So the colors are really good. This flag represents the motor. When I give it throttle, the flag will move. So that's our propeller and our motor. Okay, let's get the AR610 set up, mounted in the plane. All right, so we've got our airplane. We have our receiver. We've got a smaller screwdriver. This is a Phillips with a flat head. And then I've got an Allen driver. That is to adjust the linkage for the servo going to the control surface, and to control the servo arm and the horn. Arm, horn, backwards. One of those. That's so we can adjust that. Then we're going to look in the manuals and we're going to see the rates, the travel, the distance the control surfaces should move up and down in your high setting and your low setting, otherwise known as dual rates. A rate is how far your aileron travels. So at a low rate, it would be, we'll call it 70% of the maximum travel. The high rate, 100% of the maximum travel. And you need a way to measure all those travels. A simple ruler will get the job done. This is a tool you can clamp on the wing. I don't know the exact name of it, but you can clamp it on your plane like that and then watch in this case, the aileron go up and down, and you can measure in millimeters or inches, or we can use an angle finder, or I even have an angle finder on my phone. So there are many ways that we can figure out our rate travels and measure them. The first thing we need to do is mount the receiver. I've got some double-sided sticky tape to use to mount our receiver. There's no gyro in this receiver. This is just a 6-channel receiver. All this does is move the servo, taking a command from your transmitter. So it doesn't matter how this receiver is mounted, but it needs to be mounted firm. It needs to be mounted in place. Doesn't need to be flopping around and stuff like that. So it needs to be mounted either with double-sided tape, or Velcro, or if I can get this undone, something to secure it. All right, finally get the sticky backing taken off. All right, so the receiver is mounted. In our case, we're going to use channel 6 to power the receiver. If you were doing this in an electric airplane, your speed control would power it, and you would just plug your battery pack into your speed control, and then your speed control into channel 1 for the throttle. But we're going to power it this way. You can supply power to your receiver through any servo plug. Okay, and then we're going to be using a Y harness for our servos. So both ailerons are connected to a Y harness with a single plug, which would go into channel 2. Like so, with the orange wire to the front. You can see on your receiver, it'll tell you, you'll see a plus and a minus and an S for signal. In our case, Spectrum, the orange is signal. All right, and then our elevator is going to be channel 3. And then the rudder is channel 4. Nothing is in channel 5. We don't have any landing gear, and we don't have any flaps, so that's why we're powering through channel 6. Now, how did I know where to plug what control surface into what? Looking at your transmitter, it will show you what the default settings are. You can some transmitters you can change, you know, what servo port you want doing what, but the default settings are 1 for throttle, 2 for ailerons, 3 for elevator, 4 for rudder, 5 for landing gear, 6 for flaps. And then here's just a little extension for our bind plug. And then we just need to bind it. Okay, we need to bind it. I've got a bind plug in the little bind plug extension I made. Powering on the receiver. You see it flashing there. I'm going to hold the button down and step away a little bit so it will bind. Need to be a couple feet away. I'm watching the light on the receiver to see when it's bound. There we go. Good deal. Now we're bound up. So I got out 2 instruction manuals to look at the throw rates, the travel of the control surfaces, and to give you guys just 2 different variations, and these are 2 good manuals. So if you bought an air tractor P&P that did not come with a receiver, the directions are in here to show you where to mount the receiver and how far to set up the direction of travel for your control surfaces. In the air tractor manual, right here highlighted in yellow, you can see finally that the aileron low rate is 14 millimeters and high rate is 20 millimeters. And that means when you're moving your stick on your transmitter, when you deflect the aileron all the way, let's say to the right, 100% of the travel in your low setting, that the aileron should move up and down 14 millimeters. And when you're in your high setting, 20 millimeters. So basically they're saying that the plane will fly best between 14 and 20. If you set it below 14, it's not going to turn, nearly as sharp at all. If you set it above 20, it's going to turn so sharp it'll fall out of the sky. So that is an example right here for our air tractor. Now let's look at the uproar, because it shows a couple different things here that are real interesting. So if you bought a ARF RC airplane that doesn't come with any electronics, but it also has here the travel for your control surfaces, and they are giving 3 different ways to measure. You can see it right here in the top left, the aileron up and down. The low rate is in the left column, high rate is in the middle column, and then we won't look at 3D. It's not highlighted in yellow. So when you're deflecting your aileron, your right transmitter stick, all the way to the right in your low setting, the travel up and down should be 7/8 of an inch, or 22 millimeters, or 13 degrees. When you're deflecting your stick all the way to the right, 100% of the travel, and you're in your high rate setting, the travel is 1.5 inches, or 38 millimeters, or 22.5 degrees. Let me show you what all that means. We need to make sure all of our servos are centered in the radio or transmitter. You can see this bar graph down here. This is for the rudder, and you can see this trim tab right here is for the rudder. The rudder moves left and right, so the trim goes left and right. The throttle goes up and down, so this trim goes up and down. The same with the elevator, up and down, ailerons right to left. So the trim lever corresponds to the direction of how the stick moves. And once again, down here in the bottom of the bar graph, when you center it, the little black cursor becomes solid, and you can also hear a different tone. You can also click on the roller and go down to monitor, and you can see that our servos are centered. Aileron, elevator, and rudder are in the center there, and then over here to the right you can see that it's 0. And once again, I said this in a previous video, how the servos operate is the signal from the transmitter is in the center 0, all the way one direction is -100, all the way the other direction is +100. Watch when I move the transmitter stick here. See, we're at -100 all the way. You can see it right here, all the way to the right, -100, all the way to the left, +100. So that's how the servos receive their signal from the transmitter. You need to start out with the transmitter bound. Stop making noise. And your servo arm needs to be 90 degrees to the servo linkage rod, and it needs to be 90 degrees on the control horn here. So you can see the horn is coming straight up and the rod is going 90 degrees and then 90 degrees down. And they need to be about the same distance where it connects to the horn as it does to the servo arm. That's your good starting point. 90, 90, 90, and the same distance in the arm and the horn. We're already bound to the plane, but let's go ahead and connect again, and we'll set up our servos. Transmitter on, the plane on. That quick. A receiver with no gyro, when you turn it on, it's on. Well, let's set up our servos. Let's check the direction of travel first. When I move the right aileron stick to the right aileron should go up. You're looking for green. Move the stick to the right, the right should go up. All right, go left, red goes up. So the right stick, right aileron right, the green control surface aileron should go up. Move aileron stick to the left, red should go up. That's good. Testing the rudder. Making a right hand turn, moving the stick to the right, the rudder should turn this way, blue, as if the plane was making a right hand turn. Pushing the stick to the left would make it do a left hand turn, the rudder should go this way. So let's turn the rudder to the right, and it's backwards. So we need to reverse the rudder. Now let's check the elevator. When I pull back, that should make the airplane go up on this stick here. The yellow elevator should come up when you want to dive up. When you push the stick forward to make the front of the plane go down, the elevator should go down. So let's make it go up. And the elevator's backwards. So we need to reverse the rudder and the elevator. So I'm going to go down here to Servo Setup. Roll the scroll wheel over, one click. There's travel. Selected. We're going to move one more to the right, sub trim. One more to the right is reverse. Select. Rolling the scroll wheel down one time. The first one is throttle. Select. Rolling the scroll wheel, aileron. The next one is elevator. Select. Rolling the scroll wheel down to normal reverse. It's on normal. We're going to reverse it. Bam. Then I'm going to roll the scroll wheel back. Now elevator's highlighted. Select. I'm rolling the scroll wheel to the right. Now we have rudder. Select. Rolling it down to where it says normally reversed. And it is reversed. Now just hit the back button. All right, like we just saw, however, we had to reverse the elevator and the rudder. We're going to click down the roller one time. Servo Setup. The first setting here is travel. We're not doing travel. So we're going to select that and then roll the scroll wheel to the right. Sub trim, we're not doing that yet. There we are, reverse. So select, then roll the scroll wheel down. Your first choice is throttle. Select, roll the scroll wheel to the right. The ailerons were good. They were going in the right direction. You can see it's already by default in normal. Roll the scroll wheel to the right. Elevator, we need to reverse that. So select, roll the scroll wheel down, select. Okay, now the elevator is reversed, which is what we need for our plane. Roll back up to elevator, select, roll it to the next choice, rudder, select, roll down to reverse, select. So now our travels are correct. And then we can just hit back. A couple times to get us back out. So now when we pull back on the stick for the elevator should go up. The elevator is right. Push the elevator forward to make the nose go down. It should go down. All right. The rudder, if we're turning left, the rudder should go the same direction as the stick. So if we were turning left, the airplane would make a left turn. Right, making a right turn. Okay, the servo direction is set up correctly. Now, that's going to be the end of part one. It ran a little longer than I thought. In the next video, we're going to set up the dual rates, and we'll go through how we take those measurements and get those right. And then we'll set up a mix, just to throw one of those into the mix. And then that will conclude the basic setup of a receiver using this non-gyro AR610. Then we can use a couple of those things that we just learned to move on to an AR636 that will set up a full safe select. So, hey, thank you guys so much. Any questions, please leave them in the comments. If you're new to this channel, right now I'm doing a beginner series on bind and fly airplanes. We're doing this intermediate series of programming receivers. The next one's going to be a AR636 and then a smart receiver with safe select. If you have any video ideas, please leave them in the comments below. I need ideas. I really appreciate them. That works out good for you and I. I know what you want to see, and now I know what I need to record. So with those two series, then we're also doing your request. And then I'm also throwing in just some random stuff here and there. I promised 2 videos a week, if not more. And so that's the schedule, guys. If you have haven't subscribed, please do, and click the like button. That helps out the YouTube algorithm, and that makes the subscriber count go up. When the subscriber count goes up, that just makes me want to do this. So it's a win-win. Everybody's happy. Hey guys, thank you so much. And until next time, you'll see me here. Oh, here it is.